In this presentation, we're going to be focusing on security in the IT Foundation. We'll specifically be looking at achieving persistent security over privileged interfaces. IT Foundation management involves both security, IT operations, compliance, and services, and virtualization. We're focusing on security in this demonstration. For security, IT Foundation management provides a persistent security model with unified security practice and automatically captures forensic records across the entire IT infrastructure. Traditional practices focus primarily on the normal operation and require documentation to be done manually. IT Foundation management covers all operating states, what is called persistent security, with documentation that is automatic. In this demonstration, we will be showing a live demo of persistent security over privileged interfaces. We'll be starting with an example of the traditional approach with security dependent on network services, where we will demonstrate how security that is dependent on normal networking services fails during abnormal conditions. In this case, when we drop a Solaris server into single user mode. In the second part of the video, we'll be discussing security threats, where we will connect to the Solaris server that's in single user mode by its service processor, which does not rely on normal network services. And once connected, we'll demonstrate some of the actions that are available to us. And then finally, we will use IT Foundation management to show how with persistent security, we can maintain security control in all states, including documenting all privileged user activity and even lock out unauthorized access.
On the left-hand side of the screen, I have my connection to my managed device, and on the right-hand side of the screen, I have information from the agent about who's logging in and who's changing to root. If I go ahead and change to root, you'll see that on the right-hand side, we're going to get a message from the agent noting that I successfully was able to change to root. And so any kind of activities I do here would be at least monitored that I was logging in, changing to root, so there would be some accountability. However, if I have to bring the system into single user mode to install a patch, then things start to change, because bringing it down to single user mode will stop the network services, and our agent will no longer be running and no longer be able to log information about who connected and when they connected and who changed to root. So we can see here in a minute that we're getting information on the right hand side from our agent about system going down. We're going to get some information in our connection about the system going down, and in not too much longer we're going to see that the machine becomes inaccessible from our network connection. At this point, the system has gone into single user mode, and I'm going to have to connect to the service processor in order to install my patches. In order to do that, I type in the command to connect to service processor. And then from service processor, I can start up the console. Now the system in single user mode is asking me for the root password, but there's no agent messages going on because all agents have been stopped and the network is down. So I can go ahead and log in and do whatever it is I'm going to do. There's no record of me having connected, and there's no record of anything I do at this point. So if I wanted to be nefarious, I could add a user, and I could give that user a password that I knew, and then I could set my terminal correctly so I can edit my account. Of course, it's not displaying it correctly, but that's a terminal problem. If I change this from user number 103 to 0, I now have a root account, and I know the password to it, and it doesn't identify who I am, so I can log into this machine through a backdoor account and have fully privileged access. And there's no trace of me having created this account, no idea who did it, when they did it, no agent has reported on it because there are no agents running. And at this point I've installed my patches, and I can bring my system back up into a normal run level. Go ahead and exit out. Let the system finish its boot process and come back up into its normal mode. And at this point, I can log in with my secret account, and I have full access to the box.
That's very interesting, John. Now, is this also a case where a lot of times in failure or error mode that we'd be in a situation where network services are not available? Is that something that can happen?
Certainly. In the case of a failure of the hardware, if the machine doesn't boot properly, it can not bring up network services. If there is a problem with the network card or the cabling or the switches or the routers, it cannot come up correctly. And any number of reasons why it wouldn't be able to have network services running. It's not necessarily a situation that happens every day, but it's far from what I would call uncommon.
Okay, and in this scenario, you've obviously shown us that you can create a privileged user account. But if you were doing something very simple, such as doing configuration or patching, there would be no record that you actually did that. And sometimes those things can have knock-on effects that we aren't aware of at any given time, and then a problem may occur later on. No one knows you made this change, so now we have to go go on an Easter egg hunt mission, if you will.
Certainly, yeah. I could have edited the disk configuration files. I could have changed network configuration. I could have been doing things in a normal system administrator mode, not any kind of nefarious intent, and yet I could have still screwed it up, and it wouldn't have manifested until much later, at which point you're trying to figure out what happened and how it happened, so you can then reverse those changes without any record of the changes that were made. Then it's very difficult sometimes to find the root cause.
So how does this change with ConsoleWorks?
Well, let me show you what will happen with ConsoleWorks. With ConsoleWorks, I have a persistent connection to the service processor, console, and that's demonstrated by this window with the black background and white text. So if I were to try to connect to the service processor, and then start the console where I can do my privileged access, it's going to tell me that it's in use.
So basically, once ConsoleWorks has established its connection, it's not going to allow this unmonitored connection to be made.
That's correct. However, if I am of ill intent, I could decide that I want to stop the service processor console, in which case that will drop the connection to ConsoleWorks over on the right-hand side, and ConsoleWorks will realize that its connection is being dropped. If I were to hit return, except it immediately will start it back up again. And you can see that it starts the SP console, so it doesn't lose any information that's going to and from the console. So just because I stopped it doesn't mean that I can turn around and restart it, because ConsoleWorks has already restarted it before I can do anything. And once again, the connection is already in use, so we're in view mode only. We can't actually do anything unless we go through ConsoleWorks. So let's go ahead and do that then. We have our ConsoleWorks serial console here, and we can do that. Let's suppose I wanted to look at the disk table. I can see that there's, well, let me stop it over here in our view mode. See that there's information there. and I might even want to edit that file. Oops, etc, VFS tab. And I can see the entries in there. So any changes I make at this point are done through ConsoleWorks. If I were to add another user.
Well, what about that backdoor scenario?
Backdoor 2. User add backdoor 2. Name too long. Okay, well, BD2. There we go. And set the password for him. So we have a new user account that was created there, and you could log into the machine from that account. However, if we look at ConsoleWorks, we can see that the log file is available, and it's captured all of our data. Scrolling down here, this is the disk table that was displayed and edited, and then at the very end we can see that user backdoor was created, password BD2, new password, user add BD2. So all of the changes that were made are logged, and all of the changes are tied to a particular user that's connected through ConsoleWorks, Ingstrom connecting. So we see that it was me, we see what I typed, we see when I typed it with a timestamp, and these log files can be digitally signed and secured.
So what we've really demonstrated is the ability of ConsoleWorks to remain in a persistent state of security and capturing all forensic records of what's actually happening, regardless of what mode a device or piece of a system is actually in.
Correct.
Very good.
Thank you, Terry.
Thank you, John.